Hello there and welcome back. Today we're going to look at integration by partial fractions. Last year in pre-cal you learned how to decompose a fraction. This is a way that we can write a fraction as the sum of two or more other fractions. The process was created by an English mathematician named Oliver Heaviside. You can learn more about him by scanning the image below. You might remember that this process last year was a bit long. So I guess you could say it was a bit on the heavy side. Alright, so let's take a look at an example. We're going to use partial fractions to decompose our little rational equation right here. Now the big hint I am going to give you is this. If you can factor the denominator, that's really the rule. If you can factor the denominator, so if I factor this, we're going to get x minus 5 times x minus 2. So we're going to review how to use partial fractions here. So last year you learned that you can give each one of these factors a fraction. So you're going to give each factor a fraction. And I can write that very easy. So I can rewrite my fraction as 1 over x squared minus 7x plus 10 equals to two fractions as a sum. One of them is going to be x minus 5 as its denominator, and the other one is going to be x minus 2 under its denominator. The only thing we have to do is figure out, well, what goes on top. We've done this in elementary school math too. For example, I can write 1/6 as the sum of two fractions, one having a denominator of 2, one having a denominator of 3. I can look at the factors. We just have to determine what goes in the numerators, or the tops of the fraction. Now, since we don't know what goes in the numerators, we give them a variable. So we'll call this one A and this one B. Now, there is a rule for this one. We want to create a proper fraction. We want to create a proper fraction. So if you forgot what a proper fraction is, that is where the bottom, the power on bottom is greater than the top. So in other words, the degree on bottom has to be greater than the degree on top. So if this is a linear fraction, factor, the top has to have a power of 0. So it's just a number. It's just going to be a number like A. Over here, same thing, linear. So that's going to be, again, another number like a degree of 0. There. Next, we're going to get rid of the fractions using the old trusted maneuver by using the LCD. So my least common denominator is x minus 5 times x minus 2. And I'm going to multiply everything by that. Even the right and the left side. Other way around. So if I do this, this just cancels. And we're left with 1 equals A. This has the x minus 5, but I'm going to be multiplying by the x minus 2. Plus, this has the b, and I'm going to be multiplying by the x minus 5 right there. Next, we want to find a and b. So, to find a and b, we need to create a system of equations. I have two variables I want to find. I need two equations. Therefore, we need two equations. And you write that this is a system. We're going to create a system of equations right here. So to do that, what Heaviside said to do is we need to pick any two x values. We're just going to randomly pick two x values. I can let x be 1. I just plug it in. If I plug in, or let's say 10, I guess, trying to work out negative. If I let x be 10, my first equation would be 1 equals 8a plus 5b. Then I can let ax be 100, and that's going to give me 1 equals 98b plus 95, or 98a plus 95b, and that gives me two equations. But that again looks very complicated. So Heaviside's genius was, you know what, if I can just pick any two x values, why not just look at the zeros? So that's what we're going to do. We pick the zeros. So my first 0 is x equals 2. I get that from here. So if I let this be 0, x has to be 2. And that's going to give me 1 equals 0a minus, be careful because 0 minus 5, 5b. So we know that b is going to equal negative 1/5. This way I don't have to solve a system. I already got it. So my next 0 would be 5. So if I let x be 5, this becomes 0b. So we would get 1 equals, if we let x be 5, this becomes 3a plus 0b. And so we can get a equals 1/3. Therefore, our fraction 1 over x squared minus 7x plus 10 would become a, which is 1/3. So I can go 1 over 3 times x minus 5 plus b, which is negative 1 over 5 x minus 2. Right there. And that would be the sum of our fractions. So these two fractions would be equal to each other. Now, I have some videos linked. If you go to my website, I have some more videos on how to practice these. Please go take a look at them. They're amazing videos. I like them myself. So how do we use the Oliver Heaviside method to integrate this? Well, let's see here. Well, I can't integrate this one. You could try to use arc-trig, but you're going to find out that it fails because you're thinking arctangent. And first of all, I don't want to deal with half of 7 here. So I'm thinking, I may not want to do arc-trig. But I notice I can factor. So because I can factor, I'm going to use my partials rule. So I'm going to use my new rule. So I could rewrite my integral. We already know what this is. 1 over 3 x minus 5 minus, I'm just going to put that as a minus now, 1 over 5 oh, that was awful mathematics of me. If we let x be 2, that was embarrassing. 2 minus negative 5, that should be negative 1/3. You guys probably already caught that, so I just caught that myself. Sorry about that. That should be a 3 right there. So, anyway, so this becomes minus 1/3, x minus 2 dx. Again, don't worry about mistakes. I just caught my mistake right now because I'm looking at my answer key and I realized, man, I made a mistake there with my subtraction. Just go fix it. Anyway, so hopefully you won't make that mistake like I did. I'll hear that in the comments, I'm pretty sure. All right, so now I can integrate this. Well, when I integrate these, well, this should look a little familiar. This is our u substitution. That's going to be my u, is going to be x minus 5, du is dx. Over here, there's my u, is going to be x minus 2. My du, again, would be dx. You want to check to see if you have to divide by anything. You want to check that. But since I'm not, they're just dx's. This is okay. So now I can go straight to my answer. This is a constant. I'm going to get 1/3. 1 over x minus 5, that's just the natural log. Because remember, that is 1 over u. So that's just the natural log of x minus 5 minus 1/3. And this again becomes 1 over u again. Natural log of x minus 2 plus c1. And there's your integral right there. There's your antiderivative. Now you can clean it up a little bit. You can use your log properties. I can write this as the natural log of x minus 5 over x minus 2 plus c1 if you like. Alright, hope you enjoyed this video. Again, sorry for that mistake. It won't happen again. I promise. I will see you all in video number 2, and we'll look at some other examples. Bye.